Hello guys, how are you? So today I will be teaching you geometrical optics. Geometrical optics consists of two parts, geometrical and optics, geometry and optics. Optics means something related to light and geometry is something which you are very familiar with by through maths. Right. So light, let's talk about light. Light is made up of photons, right, according to the particle theory of light, and it helps us to see. We see through light, you already know that. How do we see through light? Light falls on an opaque object or a like transparent object, if you like somewhat opaque, translucent objects you can say. Basically something that reflects light. So it reflects light and it reaches through our eyeball, and eyeball has a lens. The lens consists of cornea plus like a lot of things, like actual lens, like that. So that eye perceives the light and forms an image is formed on the retina of the eye. Retina is basically the behind part, you might study on the biology section. So that is that, and eye works as a lens, right? Lens, what is a lens? So lens we will study later, but lens, you can consider something which takes an object and makes an image, just an optical device. For now you can consider that. So second point, light is an EM wave. EM wave means electromagnetic wave, and according to the wave theory of light, EM wave is considered as a light, right? Light can be considered as a wave also, as a photons also, different theories. Wave theory of light and particle theory of light, right? So what does electromagnetic waves consist of? Electromagnetic waves is basically electric plus the magnetic waves traveling at perpendicular. So they are perpendicular and they travel, electric and magnetic waves. So that forms an electromagnetic wave. The third point is that light can travel in vacuum. Light or generally EM, any EM electromagnetic wave can travel. Why do we specifically learn about light? We specifically learn about light because we can see light, right? We can also learn about any other electromagnetic wave. They have the basic similar properties, but we study about light because we can see light, and that is the most useful thing for, at least for humans. Maybe there can be an alien who sees X-rays, so for them some things will be similar, like speed of light, rectilinear propagation. We'll see about that. So let's say sound wave. Sound wave cannot travel through light, through a vacuum, right? Light can travel to the vacuum, but sound cannot travel through a vacuum. Like sound can only travel in a medium like air, right? So when you go to moon, when not you but astronauts go to moon, so they cannot talk to each other. They cannot talk to each other because that will consist of sound. They sound cannot travel in an vacuum. Means vacuum means no medium, no medium, absence you can say, right? So sound wave can only travel in medium, but light can travel in vacuum. Light moves with a speed, constant speed, c, in vacuum, right? So c has a value of 3 into 10 to the power 8, but you can consider it 2.97, that is some actual, but we consider 3. So 3 into 10 to the power 8 meter per second. It is the fastest thing ever. And according to Einstein, light, the speed of light is not relative. It's not relative to anything. I don't actually know how that works, but so you don't have to actually know the principles and all that stuff. We are studying classical physics, so we will study classical physics. This everything was mostly given by Newton, and Newton did not know about that stuff. Newton thought light only as particles. So light shows rectilinear propagation. Rectilinear propagation simply means that it travels in a straight line. Right, simple. And you only need this much about light in the syllabus of geometrical optics. Thank you.